A team of astronomers has discovered evidence of the existence of a new planet orbiting the star Proxima Centauri. The identified exoplanet is a sub-Earth, with approximately 1/4 of the mass of our planet. This significant discovery in our stellar neighborhood reveals that the nearest neighboring star apparently harbors an interesting number of planets with diverse characteristics, similar to our solar system, encompassing both rocky and gaseous planets. However, besides this already located planet in the habitable zone of the star, what else has been discovered in the closest star system to the Sun? When you direct your gaze to the night sky from your backyard in the direction of the Southern Cross constellation, you will easily identify Alpha Centauri to your left, below. With the naked eye, from Earth, the Alpha Centauri system is perceived as a single star, the brightest one in the Centaurus constellation and the third brightest in the entire night sky, surpassed only by Sirius and Canopus. However, at a distance of 1.3 parsecs, equivalent to 4.2 light-years or 40 trillion kilometers away from us, the system that was previously observed as a single bright point becomes easily understood as a gravitationally bound triple system. It is composed of 3 stars, with Alpha Centauri A and Alpha Centauri B being the primary ones in this system. Both components are main sequence stars. Similar to the Sun, Alpha Centauri A is a yellow dwarf with a spectral type of G2V, the same type as the Sun, while Alpha Centauri B is an orange dwarf, slightly cooler, with a spectral type of K1V. The average distance between these two stars is about 23 astronomical units. For comparison, Neptune is at an average distance of 30 astronomical units from the Sun, meaning that Alpha Centauri A and B are closer to each other than Neptune is to the Sun. It takes approximately 80 years for them to complete an orbit around their center of mass. The third element of the system is Proxima Centauri, a low-mass red dwarf star with only 1/7 of the mass of the Sun. It is located at a distance of 12,000 astronomical units from the primary pair, taking about 550,000 years to complete one revolution around the central pair. Despite having less significance in terms of physical and apparent characteristics compared to its companions, Proxima Centauri has become notable for being the closest star to the solar system and for hosting a planetary system. One of these planets is in the habitable zone, a region around the star that favors the existence of liquid water on its surface, with temperatures similar to Earth. However, not everything is wonderful in this planetary system. The star Proxima Centauri was already known to host 2 planets. The first one was discovered in 2016, and the most famous of them is Proxima Centauri B, or simply Proxima B. It is a super-Earth exoplanet, slightly larger than Earth, completing an orbit around its star every 11.2 days at a distance of 7 million kilometers, which places it in the habitable zone of the star Proxima Centauri, where atmospheric conditions and suitable temperatures allow the presence of liquid water on its surface, favoring life in some form. However, it is important to note that red dwarf stars, like Proxima Centauri, being cooler than our Sun, have their habitable zones very close to the star, making any planet in those proximities subject to intense radiation from stellar winds emitted by the star. This compromises the atmosphere of these planets. Studies show that due to its close orbit, the planet Proxima Centauri B receives 400 times more X-rays from its star than Earth receives from the Sun, which represents a disadvantage and hinders life on this exoplanet, at least according to our standards. The second planet to be discovered is Proxima Centauri C. This exoplanet was first reported in 2019 and its existence was confirmed in 2020. With a mass about 7 times that of Earth, Proxima C is likely a gaseous planet, falling into the category known as a Mini-Neptune. Proxima Centauri C is in orbit around its star at a distance of approximately 1.49 astronomical units, equivalent to 223 million kilometers, completing an orbit around the star Proxima Centauri every 5 years. Due to its large mass and distance from Proxima Centauri, this exoplanet is uninhabitable. However, the surroundings of the nearest star to us after the Sun seem to have an interesting number of planets that were unknown until a few years ago. In 2020, while a team of astronomers led by Portuguese astronomer João Faria from the Institute of Astrophysics and Space Sciences in Portugal was conducting a study on the mass of the exoplanet Proxima B using the Very Large Telescope, VLT, in Chile, they detected signs of the existence of an object resembling a planetary body near the studied planet. The VLT is dedicated to exoplanet research. The first signals emerged as a weak 5-day signal in the radial velocity data obtained from the VLT during the study on the mass of Proxima B in 2020. The detected signal was proposed as an exoplanet candidate by Faria. Due to the weakness of the signal, the team had to carry out follow-up observations with a device called Espresso to confirm that it was a new planet in orbit around the star Proxima Centauri. In February 2022, the existence of Proxima Centauri D, the third and closest planet in orbit around the nearest star to the Solar System, was confirmed. Through further studies and observations, it was discovered that Proxima D is a subearth with at least 1/4 of the mass of our planet, which is equivalent to twice the mass of Mars. This planet is located closer to the star Proxima Centauri compared to the other two already discovered. Proxima D is at a distance of approximately 0.029 astronomical units, which corresponds to 4.3 million kilometers, and completes its orbit around the star every 5.1 days. For comparison, Mercury, the innermost planet of the Solar System, is at a distance of 58 million kilometers from the Sun. The result of this study is extremely significant as it demonstrated that the radial velocity technique, used in the discovery of the 3 planets in Proxima Centauri, has the potential to reveal a population of lightweight planets, similar to ours, that could be the most common in our galaxy and potentially host ideal conditions for life as we know it. The search for other planets by Espresso will be complemented by the extremely large telescope at the ESO Observatory, currently under construction in the Atacama Desert. This telescope promises to be the most powerful ever built. If you want to learn more about other information regarding what is happening in the universe, be sure to watch the next video. Thank you for watching. If you enjoyed this content, share the video with a friend who also appreciates astronomy, and help the channel by giving it a like.